Okay, among all rectangles having a perimeter of 20 feet, we want to find the dimensions of the one with the greatest area. The first thing that we want to do is we want to draw a picture. That's what we want to do. So the first thing I want to do is draw a picture. I wasn't always a visual learner, but I found that these word problems, especially when we're dealing with shapes, sometimes it helps. It really does help to find what you're looking for using a picture. So we get that picture in our head. So I'm going to say x equals my width, and y is going to equal my length. So I'm going to have an x and I'm going to have a y. Now the perimeter is 2x's plus 2y's because in a rectangle opposite sides are congruent. So our perimeter of a rectangle is going to equal 2 times the width, right? Plus 2 times the length. So I'm just kind of reasoning this out. The problem says that we have a perimeter of 20, and we called the width x, and we're calling in the length y. So I've got this equation now, 2x plus 2y equals 20. I'm just going to hold that off. This right here is a supportive type of an equation because we want to find the area with the rectangle with the greatest area. So there's two things that they've given us. They've given us the perimeter. This is going to be helpful information in finding our true goal of the one with the greatest area. Okay, so what is area of a rectangle? Area of a rectangle is length times width, or width times length. So area is equal to x times y. This has one too many variables. One too many variables. Okay, we need an input and an output. We want to find maximum area, and remember, our maximum is our y value. So we want to find the maximum area. So a has to stay in this equation because we need it to find the maximum area. But x or y, one of those has to leave. We typically like x to be our input. So I'm going to say x is my input. Now, x is going to stand for the width. Okay? So the width and the area. Those are the two things that we're going to be comparing. How do I get rid of y? Well, we're going to use the perimeter equation. Use the perimeter equation to substitute for y. So here's my perimeter equation. 20 equals 2x plus 2y. I'm going to come over here. I'm going to rewrite it 2x plus 2y equals 20. I want to solve for y. So I'm going to substitute, or subtract, not substitute, subtract 2x from both sides. That gives me 2y equals negative 2x plus 20. Then I'm going to divide each term by 2. That's the same thing as dividing both sides by 2. And I get negative x plus 10. Now what I can do is I can take this negative x plus 10 and I can substitute it in for y. So our area formula becomes, instead of x times y, it's going to become x times negative x plus 10. Let me make sure that's very clear that that's a negative x plus 10. So area equals negative x squared plus 10x. Now what do? We want to find the max. So we want to find the max. Therefore, complete the square. Complete the square. Well, this would be extremely simple if we didn't have that leading negative, but that leading negative gives us a parabola that's opening down, so that negative is crucial for us to have a max. So we'll just factor it out. So we factor that out, And then we're going to complete the square. Half of 10 is 5. 5 squared is 25. Negative times 25 is a negative 25. Therefore, we're going to add 25 to undo it or zero it out. Now we'll have negative x minus 5 quantity squared plus 25. Our vertex is 5, 25. Remember, the first ordered pair, or the first value in the ordered pair, represents the width. The second value in the ordered pair, I'm going to change this color. Let's change this color to orange. Oh, that's a pretty color. Here, it's kind of like a peachy. Okay, and I'm going to make this blue. So our max, that second value is our max. So what did it want us to find? Find the dimensions with the greatest area. So if the width is x, x was equal to the width, y was equal to the length, and that was measured in feet, I'm going to have 5 feet, and y is negative x plus 10, so that would be negative 5 plus 10. That would also be 5 feet, negative 5 plus 10. That gives us 5 feet. So our dimensions are 5 feet by 5 feet, and the total area, that would give us a greatest area. Not that it's asking, but it would give us a greatest area of 25 square feet. So here is another video, or not another video, another problem with asking you for, among all rectangles having a perimeter of 60 feet, which one will give you the greatest area. So what are the dimensions of the one that gives you the greatest area? Go ahead and try that. So you're going to press pause, and when you're ready to rejoin us, go ahead and press play and come on back. Okay, hopefully you went through and you did all of the work, because the work is going to be very helpful. Great practice for the problems that are going to be helping us later on. Problems that we're going to be faced with in maximizing areas for animal pens and when we want to enclose a certain area, maybe at a farm or in a field. Here's the problem that you just tried, and we get 15 feet by 15 feet maximizes the area of the rectangle, and there's all the work that goes along with it. So hopefully you're feeling confident, very confident about completing the square and finding these maximum values. In the next video, we're going to step it up one more bit. We're going to have 60 meters of netting, and this time we want to build 3 adjacent rectangular cages. 3 adjacent rectangular cages. So not just one rectangle, but we're going to have 3 cages, and we want to find the dimensions so that we can get as large of an area as possible.